friends, welcome to CEC live lectures. We will be continuing with our discussion on domain name system in this lecture as a series of in series with the previous lecture. So, we were talking about the domain name system and we had seen that how names on the internet are used to identify computers instead of the IP addresses, because of the obvious reason that names are easy to remember. So, we had also seen that names could be defined as a hierarchical format, so that it is easier to identify the names, easier to identify resources within a particular system. So, this entire way or this entire schema of giving names to computers is also very structured manner it is done, and this entire space, this hierarchical name space is called the domain namespace, and this has been designed like that. So, in this design, names are defined in an inverted tree structure with the root at the top and the nodes will be at the bottom. So, the tree can have only 128 levels, that is a domain name can have max to max, it can have 128 levels or 128 subparts, that is starting from 0 it can go up to 127 subparts. So, if you look at this diagram, it clearly shows how the domain name space is organized. So, you can see that the topmost is the root and then you have the nodes. So, this is like an inverted tree because the root comes at the top and the nodes come at the below the root. So, this structure is very important because the same structure will be used to understand the entire idea of domain names and how the names are assigned. So, these are known as, there can be nodes, there can be top level nodes, and then there can be further nodes, and this is we all understand that how the nodes, and there is a parent child relationship which exists between the node and its sub node. So, the top level node will be the parent of the nodes which come under it, right. So, every node in the tree, it has a label. So, label is basically an identifier which is a string, okay, and the maximum characters in a string or in a label will be 63 characters. So, the root label is actually a null string which is an empty string because it does not have any label, and DNS requires that the children of a node will mean that the different nodes that branch from the same node, they will have different labels. So, because of this reason only, we will guarantee that there will be a uniqueness of domain name. So, as we had seen that there is a top level domain name. For example, we say that the top level domain name is com, okay. So, now com is common. Now, in com there can be several nodes, okay. Say for example, you have different companies who have the domain top level domain name com. So, you have a company called ABC, you have a company called PQR, you have a company called XYZ, right. So, this ABC, PQR or XYZ have to be unique. So, no two companies can have they can all have the top level domain name com can be same, but below this it has to be different. So, that is what we are saying, that the top level is common, but the children of one node will always have to have different labels. Therefore, we will have uniqueness. So, we will have abc.com, pqr.com and xyz.com. So, this cannot be repeated. The lower level domain name cannot be repeated. The top level can repeat, but below that it has to be different. Now, say for example, if there is a company, say ABC has got different departments. So, you have IT department, so it will be it.abc.com. It has an HR department, so it will be hr.abc.com. But there cannot be two labels or two nodes which have label IT under ABC, because that has to be unique. So, therefore, we are saying that children of the same node have to have different labels. This will only ensure that there is uniqueness. So each node in the tree has a domain name, right? Every node has a domain name. So a full domain name will be a sequence of labels separated by dots, right? So the domain names, we will always read the domain names from the node up to the root. So we will go from the bottom of the tree to the top of the tree, and the first root label, that is the last thing which will come, is a null label. As we said that the root does not have a label, so it is a null, so it will be a null string. So you will just put a dot, right? So the full domain name will always end in a dot, because the last node, which is the root node, does not have a label, so it will always have a dot there. So if a label is terminated by a null string, which is in most cases, which is the thing, then it is known as a fully qualified domain name, fully qualified domain name, or FQDN. Because why we are saying? Because it is going up to the last node, it is going up to the root node, so we say that it is fully qualified, it is fully explained. But if it is not ending in a null string, if it is not ending with a dot, then it is known as partially qualified domain name, or PQDN. So this means that PQDN will start from a node, but it will not reach up to the root. Okay, so it is used when the name is to be resolved belongs to the same site as the client site. So here the resolver will supply the missing part, which is known as the suffix, to create a FQDN. So ultimately this FQDN is created from a PQDN, but this is done by the resolver. This is done by the client, it is not automatically resolved. But most domain names that we see are fully qualified domain names, because they all go up to the root, and hence they all terminate with a dot. So if we see here how we read the domain name, so you have the root at the top, but you start reading from the bottommost node. So we will read from computer. So we will say computer dot department dot university dot edu, and then you will just put a dot, because as we said root does not have a label, so you will just put a dot. So it will be computer dot department dot top university dot edu and followed by a period. So this will be the complete domain name that you will get, right? So now what the important point to remember here is that this is a fully qualified domain name, and the children of the same node will always have different labels, they will have different identifiers. Now what is a domain? Domain is basically a subtree of the domain name space. So from the entire domain name space, if we look at a particular part, if we look at a component of the domain subtree, domain space, then it is known as a domain. So the name of the domain is the name of the node at the top of the subtree. So for example, the topmost domain or the topmost node after the root is com, so this domain is known as the com domain. If the label or if the name of the topmost node is edu, so this is known as a edu subtree. So we can see here in this, you can have the com domain, we can have the edu domain, and then within the domain also you can have domain. So within com also you can have one domain. We say for example you have firstcompany.com, and in first you have HR, and in then HR also further you can divide like that. So you can have within domain within a domain. So you can have node within a node likewise. So this entire information is contained in the domain name space, and all this information is to be stored. This is like a directory structure as we discussed earlier. So this definitely needs to be stored. Now the thing is that you cannot store the entire domain name structure or entire domain name files on one single computer, right, because it is huge amount of information considering the size and the rate at which internet is growing. So this is inefficient. Why? Because it will responding to requests from all over the world is going to have a heavy load on this system. And besides this, it is also very unreliable, because if this single computer it encounters a failure, then the entire data becomes inaccessible. So therefore the idea is also to distribute the domain name system on different servers, just like the domain name space has been distributed, right. So what we do is that we put this information on many computers instead of just one computer, which is called as the DNS servers. Now one way to do is to divide the whole space into many domains based on the first level. First level means com, edu, like this, or we can that is the root, whatever the root is, that will stand alone, and you create as many domains or subtrees as there are first level nodes, right. Now because a domain is created this way, it could be again be very large. So DNS allows domains to be divided further into smaller domains, which are known as subdomains. Because say if for example we say that we will create one .com, the com domain, we will make it into one single domain. So that is going to be enormous, because there can be millions of companies. So all companies, they have .com top level domain name. So then again this is not a practical thing. And then you make each server responsible for either a large domain or a small domain. So in other words, we have a hierarchy of servers in the same way that we have a hierarchy of names. So we are dividing the storage servers also like the way we have distributed the namespace. So we can see here that you have a root server, and then you have further the top level server like edu server, com server, etc. And then within the server you can have separate other servers also. So this way you are dividing, or you are creating a hierarchy of domain names, and you are creating a hierarchy of the name servers which are storing this information of the domain names. Now we also look at the jurisdiction, or we also look at the area, or we also look at the span of the server, right, because we say that the complete domain name hierarchy cannot be stored on a single server, right. So we are saying that we divide the entire hierarchy into several servers. Now what a server is responsible for or has authority over is called as a zone. So we can define a zone as a contiguous part of the entire tree which is under the control of a server, right. Now if a server accepts the responsibility for a domain and does not divide the domain into smaller domains, right, in that case the domain and the zone will refer to the same thing, because the server is not further dividing its domain into smaller domains, right. So it remains the same, the domain and the zone will remain the same, but the server can divide the domain into subdomains, okay, and then it can again delegate part of its authority to other servers. So in that case the domain and the zone will refer to different thing, because the domain will be larger but the zones will be different, because it is dividing the zones, it is sort of giving the or delegating its work to other servers, right. So if in the first case where we have the domain and the zone is the same, that is the server is not subdividing the domain into other servers, it is not distributing its work, in that case the server will make a directory or a database which is called as a zone file, okay, and it will keep all the information for every node under that domain. right? In the second case, the information, because now we have subdomains created under the domain, so information about the nodes in the subdomains will be stored in the server at the lower level, with the original server keeping some sort of reference to these lower level servers. So now your main server, the one which is at the top, okay, which has got the domain rights, it is only going to have pointers, or it will only have references to the lower level servers, but the database, the real database, will be maintained by the lower level servers in whose zone this is coming. So we cannot say that okay, in this case then the original server has freed itself from the responsibility. It's not the case, because it still has a zone, but the detailed information is kept by the lower level server. The zone is there, but in its zone, instead of having the nodes, now it is having the lower level servers, to which has a pointer to it. It does not contain the detailed level information like the the domain servers, which have the same domain and zone would have. They have only summarized kind of information. So this diagram also shows us that how the domain and zone can vary. So if it is the .com server or the .com domain node, so in this case the domain is the com, but its zone is, because it's a very large zone, so it has created other servers, it has delegated other servers, and in the lower, the blue triangle which we see, that is a server whose zone and domain is the same, but the zone and domain of the com server is definitely different. Its domain is smaller, zone can be bigger, but in the other case the domain and zone are same, because it is not sort of further subdividing its responsibility or its the database which it is going to maintain. Now the root server is basically a server whose zone consists of the whole tree, because the root is at the top. So the root server will not, it does not generally store any information about domains, but it delegates its authority to other servers, keeping references to those servers. So again the top level also is the same thing, because there can be several root servers also, and each root server is covering the whole domain name space. So root servers are distributed all over the world. Why this is done? Why this kind of redundancy is maintained? Again, to this is a plan to coping or mitigating with the chances of any failure, so that the system cannot stop. Even if a few root servers don't work, the others will take it up. So therefore root servers, they are located at different places in the world, and but they definitely they do not have information, but they only have references of the other servers to whom information has been, to whom responsibility or the charge has been delegated. Now there are two types of servers also here. The DNS basically defines two types of servers. First is the primary server, the second is the secondary server. So the primary server is basically a server which stores a file about the zone for which it has an authority. So it is responsible for creating, maintaining and updating the zonal file. It will store the zone file on a local disk. So basically the primary server is going to create and update and maintain the entire information about its zone in a zonal file. A secondary server on the other hand will it will have the complete information about the zone, but it will take that information from another server. It will not create any zonal file, it cannot update a zonal file, it only maintains the zonal file. So now this secondary server could take the information either from a primary server or from another secondary server, right? But the idea is that it will never create or update the zonal file. If updating a file is required, then it is only done by the primary server which sends the updated version to the secondary server. So, the primary server is the one which is creating and updating. The secondary server is only having a copy of the zonal file which it receives from the primary server. Now, primary and secondary servers, they are both authoritative for the zones that they serve. So, it is not that the secondary server is lower level of authority, or it's not like that, but it is only to create redundancy for the data, so that if one server fails, the other can continue serving client. So, if a primary server will fail, then the secondary server will have a copy of the information. Also, the same server can be a primary server for a specific domain, for a specific zone, and a secondary server for another zone. So, it is not that if it is a secondary server, it will only be secondary server for all the zones. No, it is not like that. It could serve as a primary and a secondary server for different zones at the same time. So, DNS basically is a protocol that is used in different platforms, right. So, when you are considering DNS on the internet, right, so the original tree which was used was divided into 3 different sections, right. So, the first section was the generic domain names, the second section had the country domain names, and the third was the inverse domain name. Now, the inverse domain name is not used anymore, because this was actually a reverse mapping, that is going from a domain name to an IP address. But due to the rapid growth of internet, it becomes extremely difficult to keep track of inverse domains. That is, if you give me a domain, I give you an IP address, that was not possible. So, therefore, now inverse domains have been deprecated, they are now out of use. So, the 2 main types of domains which are used are generic domains and country domains. So, generic domains basically they define the registered hosts according to their behavior. We had seen initially also that we were saying that one part of the domain name is the top level part of the domain name is given by a central authority. Now, how does the central authority give it? It gives the domain name based on the behavior, right. So, each node in the tree defines a domain which is an index to the domain name space data. So, different generic domains can be there, like we have .com, .in, .org, .net. So, depending upon .gov, what type of organization is using the domain name, accordingly the generic domain label will be given to the organization. The second type of domain names which are used on the internet are country domains, right. So, country domain section uses 2 character country abbreviation. For example, we use .in for India, .us for United States, .uk for United Kingdom. So, second labels can be organizational or they can be more specific national designation. Like for example, in India we will only have .in, right. But in case of USA, they will also have a second level or second label domain name, like they will have for the states, they identify with the state also. So, say for example, subdivision California, so they will write .ca.us. So, this means that it is CA is a subdivision of the country domain. So, if we look at an address, say for example, uci.ca.us, right. So, if you translate this, it means that we are talking about a particular university in the state of California in the United States. Although in India, if you look at it, you will write like du.ac.in. So, here we are qualifying how? We are qualifying IN is India, AC is the behavior of the organization, the nature of the organization, and DU of course is the name. So, you can we have slight variation according to the structure of the country or according to the the policies of the country in which the domain names are going to be used. So, if we look here, different countries they have a root level, and then you can have different types of domain names, country domain names. Now, another important aspect is that how the new domains are added, right. So for this, like whenever somebody wants to start a new company, so they have to go and get the company name registered with an agency. So likewise here also, when you have when you want to get a new domain name added, then this is also done through a registrar. So a commercial entity which is accredited by the ICANN. Now what is ICANN? It is the Internet Corporation for Assigned Names and Numbers. So this is the entity which looks at the aspect of assigning names or domain names to the different stakeholders. So this Internet Corporation for Assigned Names and Numbers is basically a multi-stakeholder group. Okay, it's an American non-profit organization which is responsible for coordinating and the maintenance and procedures of several databases related to the namespaces and numerical spaces of the internet, ensuring that network stable and secure operations are carried on. So basically what happens is that when a person goes to the registrar, he will first verify the requested domain is unique and enters it into the DNS. Of course, a fee is charged for this, and one can find out, there is a particular link on which you can find out what are the domain names which have already been taken. Now to register, the organization needs to give the name of its server and the IP address of the server, right. So if any commercial entity has to open its domain name, they have to give the IP address also on which the domain name is going to be hosted. So basically when a company or when an individual approaches the registrar, they have to give the domain name and the IP address of the host, so that the entire thing can be mapped and it can be uploaded on the DNS database. Once it is uploaded on the DNS databases, the search engines can automatically scan through those and they will get to know that okay, this domain name has been added to the list of available domain names. So this is all about the domain name system and how the namespace is organized on the internet. We will be continuing with some other protocols in the standard client server protocol series. Till then, take care. Thank you so much.